Thanks for joining this class, Great Minds. In this class, I will be teaching you the topic trigonometry. Trigonometry is a field in mathematics that is dedicated to the study of triangles. In this class, I will be teaching you how to find the length of the unknown side of a right-angled triangle. I will also be teaching you how to find the unknown angle of a right-angled triangle, as well as how to solve problems involving right-angled triangles. So, in the first part of this class, let's find out how to identify the different sides of a right-angled triangle. Recall that a right-angled triangle is a triangle in which one of its angle is equal to 90 degrees. So how do we identify the size of a right-angled triangle? A right-angled triangle has three parts or three sides, namely the hypotenuse, the opposite, and the adjacent. To identify the size of a right-angled triangle, you must first identify the hypotenuse. The hypotenuse of a right-angled triangle is the longest side and the side that is opposite the right angle, which is 90 degrees. So the side that is opposite the right angle is the hypotenuse. Next, you identify the opposite side. The opposite side is the side that is opposite the given angle. Usually in any particular question, you will be given a particular angle. The side that is opposite that given angle is the opposite side, and the remaining side automatically becomes the adjacent side of the right angle triangle. So I'll repeat again for the purpose of emphasis that the side opposite the right angle is the hypotenuse, while the side that is opposite the given angle for any particular question is the opposite side, and the remaining side becomes the adjacent. So we are going to use this example to identify the size of a right angle triangle. If you consider this triangle based on the angle alpha, then the opposite side will be the A, which is the side that is opposite the right angle. So A will be the opposite side for this right angle triangle, while the B will be the adjacent. B will be the adjacent side of the right angle triangle, while the small letter C will be the hypotenuse. So for this particular triangle, when you consider it based on alpha, A is the opposite, B is the adjacent, while C is the hypotenuse. But if we are to consider this triangle based on beta, which is the second angle given in the question, in that case A will become the adjacent, because A is the side that is next to the hypotenuse. A will become the adjacent, while B will become the opposite, and C will still remain the hypotenuse because it's the side that is opposite the right angle. There are three basic trigonometric ratios which we have in trigonometry or for right angle triangles. You have the sine, the cosine, and the tangent. To identify these different trig ratios and the formula used to solve them, the sine of an angle is the opposite all over the hypotenuse, while the cosine of any angle, to find it, is the adjacent all over the hypotenuse, and the tangent is the opposite all over the adjacent. A quick way to remember this is the acronym SOHCAHTOA, where SO stands for sine and is the opposite all over the hypotenuse, and CA stands for cosine and is the adjacent all over the hypotenuse, while TOA stands for tangent of angles and it is the opposite all over adjacent. So we are going to apply this knowledge of trigonometric ratios to find the length of an unknown side of a right angled triangle. So we are going to take some few examples on how to find the length of an unknown side of a right angled triangle. So let us consider our first example. Let us consider our first example. We are told to find the value of x in the triangle that you have in your screen, where the triangle is a right angle triangle, and we are asked to find the value of x. To find the value of x, we are going to use sine, because we have we are looking for the opposite while we were given the hypotenuse, so we are going to use sine. So the sine of 29 degrees will be equal to the opposite, which is x, all over the hypotenuse, which is 8. And so when you cross multiply, you are going to have x being equal to 8 times sine 29, which makes x to be equal to 3.8. Let's take another example. You are told to find the height of the plane that is the height of a plane that is h above the ground level. We are to find the perpendicular height of the airplane. In this particular question, the first thing you do is to identify which of the trigonometric ratios you are going to use. In this case, we are given the hypotenuse while we are looking for the adjacent, and so in this case we are going to use cos. The cosine of 60 degrees is equal to the adjacent, which is h, all over the hypotenuse, which is 1000. When the cosine of 60 degrees is 0.5, and so when you cross multiply that expression, you are going to have 0.5 times 1000, which is equal to 500 meters. The next aspect we are considering in this class is how to find an unknown angle of a right angle triangle. Supposing you are asked to find an unknown angle of a right angle triangle, how do you do that? So let's take an example. We are asked to find the size of the angle marked S in the diagram that you see, in the triangle that you see on your screen. To find the value of x, you look at the size which you are given. We are given the opposite as well as the hypotenuse. So which of the trig ratios are we going to use? We are going to use the opposite all over hypotenuse, which is the sine of the angles. So we are going to use trigonometric ratio sine to solve it. So sine x now, which is the angle we are looking for, is the opposite, which is 3, all over the hypotenuse, which is 8. So sine x will be equal to 0.375. When you take the sine inverse of that value, 0.35, you are going to have 22.02. So let's take another example. This time around, you have another airplane, and we are told to find the value of the marked angle S. So we are to find this marked angle X, we are going to ask ourselves, what is the size that is given? You are given the opposite, and then you are also given the adjacent. Opposite and adjacent, when you compare with the acronym SOHCAHTOA, TOA, that means you are going to use TOA, which is tangent of angles. And so to find the tangent of the angle X is equal to the opposite, which is 300, all over the adjacent, which is 400. Tan X, it will be equal to 0.75. When you take the tan inverse of 0.75, you are going to have X being equal to 38.87 as your value of X. In the next part of this class, we are going to be looking at complementary angles. So what then are complementary angles? Two angles are said to be complementary if they add up to make 90 degrees. So please take note of that. Complementary angles are angles that when you add them up, you are going to get 90 degrees. The knowledge of complementary angles help us to find the unknown angle for right angle triangles. So from the diagram, if you consider the angle based on theta, the sine of theta will be the CA, which is the opposite, all over the hypotenuse, which is CB. If you consider the angle based on 90 degrees minus theta, the cosine of this angle will be the adjacent, which is CA, all over the hypotenuse, which is also CB. So comparatively, the two angles are equal. So the knowledge of this will help us to be able to solve a question like this. Solve the following equation. Sine theta is equal to cos 53 degrees and sine 2 theta is equal to 3 theta. There are two methods which you can use to solve this particular problem. So we are going to I will teach you the two methods. The first is that sine theta is equal to 53 degrees, which is the question. But we know that sine theta is equal to cos 90 minus theta. And so when you substitute cos 90 minus theta wherever you find sine theta, you are going to have cos 90 minus theta being equal to cos 53 degrees. The cosine will cancel out each other on both sides of the equality sign, leaving you with 90 degrees minus theta being equal to 53 degrees. When you make theta the subject of formula, you are going to have 37 degrees. Let's look at the second method which you can use to solve this problem. Just add up the two angles, which is theta and 53 degrees, and equate it to 90 degrees because they are complementary angles. They add up to make 90 degrees. When you do that, you are going to have theta plus 53 degrees being equal to 90 degrees. And when you make theta the subject of formula, you are going to have 37 degrees as your answer as well. In the next question, which is the question B, we'll use the method 1 to solve it. Sine 2 theta will be equal to cos 3 theta, but sine 2 theta is the same thing as cos 90 minus 2 theta. And so in place of 2 theta, you can replace it with cos 90 minus 2 theta. When you do that, the cosine will cancel out themselves on both sides, leaving you with the answer. The second method you can also use as well is add up the two angles to make 90 degrees. And when you add up the two angles to make 90 degrees, you are going to have 5 theta being equal to 90 degrees. And when you make theta the subject of formula, you have 18 degrees as your answer. Thanks for watching this video. I'll see you next time. Bye bye.